In this problem, we're given two linear equations and are asked to graph them to determine if they are parallel or perpendicular. Before I start graphing either one, I am going to write them in slope-intercept form, which means I will need to solve for y on both equations. Let's start with the first one. 2x minus y is equal to -1. To solve for y, I'm going to first subtract 2x from both sides to start to get y by itself. So I will have minus y or negative y. This is a mistake a lot of people make. They forget to keep that negative in front of the y, is equal to, and I'm going to also go and write my slope first. So minus 2x and then minus 1. Now I still need to get y by itself. If you notice, y has a negative in front of it, so you can almost think of it as not negative y, but negative 1y. So to get the negative 1 away from there, I would need to divide everything by negative 1, which means everything's just going to flip to its opposite. So I will have y is equal to 2x plus 1. A negative 2 divided by negative 1 is positive 2. A negative 1 divided by negative 1 is a positive 1. For my next equation, again, I'm going to solve for y. First, I'm going to solve by subtracting x from both sides. So I will get 2y is equal to, I'm going to write my slope first, negative x minus 6. And then to solve for y, I'm going to divide both sides by 2. So I will get y is equal to negative 1/2 x minus 3. The negative x divided by 2, it needs to be written as a fraction. Again, if you want to think about the x having a 1 in front of it to help you picture that. And then negative 6 divided by 2 is a negative 3, so that's why I got the minus 3. Now let's go ahead and graph to determine if these are parallel or perpendicular or neither. The first one says y is equal to 2x plus 1. My slope is 2 over 1, and my y-intercept is positive 1. So my y-intercept, I'm going to go to positive 1 on the y-axis, and then my slope will be rise 2, run 1. Rise 2, run 1. I'm going to do a few more points on the left side of my y-intercept, so I'm going to go down 2 and to the left 1, down 2 and to the left 1. Once you have a few points, again, you can go ahead and connect them using as straight a line as possible. Sometimes it even helps if you use a ruler if you're doing this on paper. For my second equation, I have y is equal to negative 1/2 x minus 3. My minus 3 is my y-intercept, and the slope is negative 1/2. So my y-intercept, I'm going to plot that first, negative 3. And then my rise over run will be down 1 to the right 2. Down 1 to the right 2. And then I'm going to also plot a few points to the left side so I can see if these intersect at all. Up 1 to the left 2. Up 1 to the left 2. Okay. Connecting these lines, or these points, I am going to notice that these two linear equations are intersecting at a 90-degree angle. That means that these are perpendicular lines. Another way to remember that these are perpendicular, my apologies, is they have what's called opposite reciprocal slopes. That just means the slope over here is technically considered to be 2 over 1. The slope over here, or the second one, is negative 1 over 2. Opposites meaning one is positive, one is negative, and reciprocals meaning the numerator and denominators have essentially flip-flopped, or the top number and the bottom number in the fraction. So that's another way that you can tell that these two lines are perpendicular.